Welcome back. Section 2.2. In section 2.2, we introduce quadratic functions. In this section, we will discuss and identify important characteristics of parabolas, graph parabolas, determine a quadratic function's minimum or maximum values, and also solve problems, application problems involving quadratic functions minimum or maximum value. Graphs of quadratic function. Let's discuss or identify some of the key characteristics of quadratic functions. So if you have the quadratic function, f of x is equal to ax squared plus bx plus c, where a is greater than 0. So if the leading coefficient a is greater than 0, then the parabola opens upward, as we have here. It opens upward. The vertex is the vertex. When it opens upward, we see that that vertex corresponds to a minimum point. It's a minimum. And another important characteristic is the equation of the axis of symmetry. The axis of symmetry is the line through the x-coordinate of the vertex. So if a is greater than 0, the parabola opens upward. On the other hand, if a is less than 0, the leading coefficient is less than 0, the parabola will open downward. When it opens downward, the vertex corresponds to a maximum point on the parabola. And the axis of symmetry again would be the line through the x-coordinate of the vertex. Continue our discussion of quadratic functions. In this section, we want to begin to look at how we would graph quadratic functions. So let's first look at graphing a quadratic function in standard form. So the standard form of a quadratic function is f of x is equal to a times x minus h squared plus k. Of course, a can't be 0. Expressing the quadratic function in standard form allows us to immediately identify the vertex. So by looking at, the function expressed in standard form, we can immediately identify the vertex. The vertex, the coordinates of the vertex would be h, k. And the axis of symmetry is the line through the x-coordinate of the vertex. So x is equal to h. The vertical line through h. Next example, we want to actually graph a quadratic function. And the function is expressed in standard form. And what we recall, remember, the standard form, f of x is equal to a times x minus h squared plus k. So in our example, a is a negative 1, h is 1, and k is 4. All right, let's make some notations here for step 1. We also notice that a, which is a negative 1, a is less than 0. When A is less than 0, the parabola opens downward. All right, so that's the first thing. Step 2. Let's find the vertex. In standard form, the vertex will have coordinates h, k. H is 1, k is 4. So the vertex of the parabola is 1, 4. Step 3. Let's find the x-intercepts. Find x-intercepts. All right, to find the x-intercepts, we let f of x be 0. So if f of x is 0, I have 0 is equal to minus x minus 1 squared plus 4. We want to solve this for x. So by transposing a negative x minus 1 squared from the right to the left-hand side, I have x minus 1 squared is equal to 4. If I use the square root property, I have x minus 1 is equal to plus or minus the square root of 4. So I have x minus 1 is equal to plus or minus the square root of 2. So therefore, x is equal to 1 plus or minus 2. So when we add 1 plus 2, so 1 plus 2, I get 3. And when we subtract 1 minus 2, I get a negative 1. So the x-intercepts occur when x is 3 and when x is minus 1. Now we need the y-intercept. Let's call it step 4. So for step 4, put it up here. Step 4, we want the y-intercept. To find the y-intercept, we merely just need to evaluate the function at 0. In other words, what is f of 0? If I evaluate the function at 0, I get minus 0 minus 1 squared plus 4. Simplifying this, I get minus a minus 1 squared plus 4. This is minus a negative 1 squared is 1 plus 4. A negative 1 plus 4 is 3. So the y-intercept is at 3, 0, 3. And the last step is to find the axis of symmetry. The axis of symmetry is the line, the vertical line, through the x-coordinate of the vertex. In this case, it's 1. So it's the line through 1, the vertical lines through 1. So now that we have gathered all of this important information, let's now graph the quadratic function. All right, so let's see. We know that the vertex is 1, 4. Up 1 over 1, up 4. So here's my vertex. We know that the x-intercepts are 3, 0, and a negative 1, 0. A negative 1, 0 is here. 3, 0 is here. And now the y-intercept. The y-intercept is the point 0, 3. 0, 3. All right. And we also know that the parabola opens downward because a is less than 0. So now if I connect the points, and the axis of symmetry is the vertical line through x is equal to 1. And now we have obtained the graph of the quadratic function f of x is equal to minus x minus 1 squared plus 4. Now we want to graph quadratic functions expressed in the form f of x is equal to ax squared plus bx plus c. If we actually complete the square on ax squared plus bx plus c, we find that the vertex of the parabola expressed in this form would be minus b over 2a and f of minus b over 2a. All right, so if the quadratic function is expressed in the form ax squared plus bx plus c, the vertex, the coordinates of the vertex are a negative b over 2a and f of a negative b over 2a. In other words, the y-coordinate is obtained by evaluating the function f at minus b over 2a. In this example, we want to graph the quadratic function given in the form f of x is equal to ax squared plus bx plus c. So, and then of course, after we graph, we are going to identify the domain and the range of the function. So again, let's gather some important information. All right, step one, we notice that in the function a is less than 0. A is equal to 1. So a is less than 0, which means that the parabola opens downward. So the parabola opens downward. 2, the vertex. Let's talk about the vertex. All right. We said that the x-coordinate of the vertex is given by a negative b over 2a. So what is this? This is minus b is 4 over 2 times a. A is a negative 1. So 2 times a negative 1, simplifying, I have a negative 4 over a negative 2, which is 2. So the x-coordinate of the vertex is going to be 2. What is the y-coordinate of the vertex? Well, to obtain the y-coordinate, we then want to evaluate the function f at 2. So we really want f of 2. X is 2. To get y, we evaluate the function at 2. So what do we have if we do that? We have a negative 2 squared plus 4 times 2 plus 1. Simplifying, we have 2 squared is 4, so a negative 4 plus 8. 4 times 2 is 8 plus 1. A negative 4 plus 8 is 4. 4 plus 1 is 5. So the y-coordinate of the vertex is 5. Three, let's find the x-intercepts. The x-intercepts. So again, to find the x-intercept, we want f of x to be 0. So we will have minus, we have 0 is equal to minus x squared plus 4x plus 1. The right-hand side doesn't factor. We can complete the square, or we can use the quadratic formula to find x. So let's use the quadratic formula. You may recall that the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's find x using the quadratic formula. All right, so in this case, we have b is 4, so that's a negative 4 plus or minus the square root of b squared, so that's 4 squared minus 4 times a. A is a negative 1 times c. C is 1. All divided by 2 times a. 2 times a. A is a negative 1. Now let's simplify this. Simplifying this, we get I get a negative 4 plus or minus the square root of 4 squared is 16 minus 4 times a negative 1 is a positive 20. All divided by 2 times a negative 1, which is a negative 2. All right, simplifying this, we get a negative 4 plus or minus all right, why did I write 20 here? A negative 4 times a negative 1 is 4. I have 20, so let me erase it. A negative 4, negative 1. So a negative 4 times a negative 1 is a positive 4. All right, 16 plus 4 under the radical. So continuing to simplify, we have a negative 4 plus or minus the square root of 16 plus 4, which is 20, divided by a negative 2. All right, let's simplify this. The square root of 20 is 4 times 5. The square root of 4 is 2. So this is a negative 4 plus or minus 2 times the square root of 5 divided by a negative 2. So if I simplify this, a negative 4 plus or minus the square root of 2 times the square root of 5 divided by a negative 2, we get 2 plus or minus the square root of 5. All right, so the x-intercepts would be, all right, and we need to compute this. On one hand, we have 2 plus the square root of 5, so we're going to get x is equal to 2 plus the square root of 5 is a positive 4.2, and 2 minus the square root of 5 is x is equal to a negative 0.2. So these are the x-intercepts, 4.2 and a negative 0.2. And the last, let's find the y-intercept. All right, the y-intercept. All right, the y-intercept, we basically, again, want to evaluate the function at 0. So if we evaluate the function at 0, we get a negative 0 squared plus 4 times 0 plus 1. So we're getting 1. So the y-intercept is 0, 1. And finally, the axis of symmetry would be the vertical line through the x-coordinate of the vertex. X is equal to 2. So now, let's put all, using the information gathered, we can now obtain the graph of the quadratic function. All right, the vertex, 2, 5, vertex, 2, 5. All right. The x-intercepts, 4.2, 4.2, and a negative 0.2. All right, also the y-intercept, we found the y-intercept to be 1, so we have 0, 1. And from step 1, we noted that a is less than 0, so the parabola opens downward. So to obtain the graph, we merely just connect the points. So we have the graph of the function f of x is equal to a negative x squared plus 4x plus 1. Let's now discuss minimum, maximum, and minimum values of quadratic functions. So given the quadratic function in the form f of x is equal to ax squared plus bx plus c, let's recall what we have said here. We said that if a is greater than 0, then f has a minimum. So f has a minimum that occurs at x is equal to minus b over 2a. So this is the location, but the actual minimum value is f of minus b over 2a. So this is the minimum value, and this is where it occurs. All right, so if f is greater than 0, just to remind you, if f is greater than 0, the parabola opens upward, so you'd expect that vertex to represent a minimum. We also said that if a is less than 0, then the function f has a maximum that occurs at x is equal to minus b over 2a. The actual maximum value is f of minus b over 2a. And again, if a is less than 0, then the parabola opens downward. Then you would expect at the vertex that you have a maximum. Let's consider the function f of x is equal to 4x squared minus 16x plus 1,000. What we want to do is to determine, without having to graph the function, whether the function has a minimum value or a maximum value. So in part A, determine without graphing whether the function has a minimum or a maximum. But we notice that in the function, a is 4. All right, a is equal to 4. So it's greater than 0, so the parabola since a is greater than 0, the parabola opens upward. And since it opens upward, it has a minimum value. All right, so without having to graph the function, we've decided that the function will have a minimum value. Part B, find the minimum or maximum value and determine where it occurs. Well, we've decided that it's a minimum. It's going to be a minimum. It's a minimum. How do we find that minimum? We said that to find the x coordinates, in other words, we want the coordinates of the vertex. And to find the x coordinate of the vertex, we have a negative b over 2a. A negative b over 2a. B in this case is a negative 16, so we have minus a negative 16 divided by 2a. 2 times a is 4. Simplifying, we have 16 divided by 8, which is 2. So the minimum value will occur at x is equal to 2. And now, what is the minimum value? To get the minimum value, we now evaluate the function f at 2. So I really want f of 2. All right? F of 2, let's find f of 2. So we have 4 times 2 squared minus 16 times 2 plus 1,000. So if we do the math, we have 4 times 4 minus 32 plus 1,000. So what do we have here? We have 16. 4 times 4, 16 minus 32 plus 1,000. And this is equal to 984. So the minimum value is 984, and it occurs at x is equal to 2. Part C, identify the function's domain and range. So by looking at the function, 4x squared minus 16x plus 1,000, it's a polynomial quadratic function, and we clearly see that the domain is going to be the set of all real numbers. So the domain is going to be from negative infinity to infinity, the set of all real numbers. Now the range of this function, well, we know that the minimum value is 984. That's the smallest value that the function can have. So the range then would be from 984 to infinity. So that would be the range of the function. Okay. The last example in this section is to consider an application problem of quadratic functions. So let's see what the problem is. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. And what is the maximum area? So the first thing we need to decide is what must be maximized. Well, we're going to maximize the area. We're going to maximize the area. What we do not know are the dimensions of the rectangle. So once we know the dimensions, we want to maximize the area. So in other words, we need to transform this into a function in one variable. So how do we do that? Well, what do we know? We know that we have 120 feet of fencing. All right, so we know, in other words, we have a perimeter of what? 120. So let's let x represent the length. All right, the length is x, and let's y be the width of the rectangle. All right, and since we have 120 feet of fencing, all right, I know that I can represent the perimeter. The perimeter of this rectangle as 2x plus 2y is equal to 120. So since I want to ultimately express a as a function of one variable, let me now express y in terms of x. So I now want to solve this for y. In order to do this, I have 2y is equal to 120 minus 2x. So if we divide both sides by 2, if I divide by 2, we have y is equal to 60 minus x. So I've expressed the width in terms of x, the length. So what we have now is, we have that A is equal to x times y, but y is 60 minus x. So expressing A as a function of x, we have 60x minus x squared. In other words, A of x minus x squared plus 60x. So we've expressed A as a function of x. Now we need to determine, now we want to actually determine the dimensions as well as compute the maximum area of this triangle. So we know that in this example, let's use what we know. We know that A is a -1. A is a -1. So in order to get the x coordinate of the vertex, in other words, the x value gives us the location of the maximum. So let's see. So x, the length would be minus b over 2a. So a -b divided by 2a is going to be a negative, b in this case is 60. So a -60 over 2a. A is a -1, so I have 2 times a -1. Simplifying, we have -60 over a -2, which is 30. All right? So the x coordinate is 30. So the x coordinate of the vertex is going to be 30. So the length, all right, is 30, and the width, but we've expressed the width as 60 minus x. So 60 minus 30 is going to be 30. So we have the dimensions of the rectangle. So the dimensions are going to be 30 by 30 feet. All right, 30 by 30 feet. Now, with these dimensions, we can now easily compute the area of the rectangle. So the area is going to be A, all right, x times y, so this is going to be 30 times 30. So we get a maximum area of 900 square feet.